Okay, so this is arguably my favorite unit of the semester, although I don't know, I really like the last 3 units that we've talked about, or the last 2. But this is environmental. We're going to basically do 3-week version of the environmental exercise physiology class. As I stated before, I teach an environmental exercise physiology class every other year, so I teach it next in the spring of 2023, so next spring. And basically we take what we've talked about here, but we expand it over an entire semester, and we get into some other stuff, and we do some labs, that sort of thing. So we're going to break up the environment into 2 parts, and the first part, these are the objectives for the lecture. All right, so when you think about the environment, just think of it in terms of it's a bunch of stressors, right? And so when we talk about stressors, there's all sorts of things. So we've talked about how exercise is a stress. And so what we're doing with environmental exercise physiology is now we're taking into account the actual environment. And so not only does this involve exercise, but the heat, cold, hypoxia, which is low oxygen, hyperbaria, so this is what you'd experience if you go scuba diving, that sort of thing. And then ultimately, we're going to talk about adaptations, which we talked about during Unit 4, like what happens when you train aerobically or anaerobically or go through resistance training. So now we're going to talk about, with each of heat, cold, and hypoxia, what are the adaptations that occur if you're exposed to this type of stress for a long period of time. Okay, and so when it comes to dealing with the environment, we can call it acclimatization. And so this is what happens if you adapt based on exposure to a natural environment. Okay, so for example, we all, or most of us, live in the Midwest, and as you know, spring, thankfully it's still cold. I'm not ready for the heat, although I'm not ready for the tornadoes that are allegedly coming today. As we go throughout the summer, we're going to acclimatize to what's going on. Okay, so we're changing, or our body's physiological responses will change to the heat as we go from the beginning of summer to the end of summer. We can also experience acclimation, and so this is essentially the exact same thing as acclimatization, only we're getting this acclimation in an artificial environment. And so this would be something like, hey, you just go spend 8 hours a day in the environmental chamber that's set to 100 degrees or something like that. Now, there's also some genetic components to this, and so these are semi-permanent or maybe even permanent changes that occur over many generations of time. Okay, and so we'll talk a little bit about it. We'll mention it briefly, especially when we talk about altitude. There are 3 main groups of people that are studied to understand the effects of altitude. Genetic effects, and they're the people that live in the highlands of Ethiopia, people that live in the Andes Mountains, and people that live in Tibet. Okay, they've lived there for different periods of time, but what's really interesting is that their adaptations are very, very different. Okay, so for example, the Tibetans, they breathe more, even because they're at high altitude, which causes them to breathe more, but the people in the Andes actually don't breathe more, but they have a higher red blood cell count. Okay, so 2 ways to deal with the same challenge. All right, when it comes to temperature, we've got some terminology that we want to think about. So we've got heat, and so heat is just a measure of the amount of energy in motion. Okay, you have to remember that molecules move around; they don't just sit still. The faster they move, the hotter it gets, and this is why temperature speeds up reactions, because all that's happening is we're speeding up how fast these molecules are moving. Heat is energy, and it can be stored, it can be converted, or it can be transferred. Okay, and so we can convert it from chemical to potential to kinetic energy, or in different forms. Okay, so this happens with metabolism, or it can be transferred. So we've got radiation, conduction, convection, evaporation, condensation. When it's transferred, we always go down a gradient, right? I talk about gradients all the time. So you always go from high temperature to low temperature. Now, when it comes to temperature, it's just giving us an idea of how hot or cold something is, but it's a measure of that energy. So in this case, it's a measure of the average kinetic energy, or the speed with which particles or molecules are moving. Okay, we express it in terms of degrees based on the scale, right? So we've got 3 different scales that you've probably heard of. So you've got Fahrenheit, Kelvin, and Celsius. Okay, and so Fahrenheit, this is the one that everybody in the world nobody in the world uses except for those of us in the United States and Belize. All right. And with Celsius, that's the one that most people use. So Fahrenheit, it was just kind of an arbitrary thing. So freezing is at 32 degrees Fahrenheit, boiling is at 212, whereas Celsius, it makes a little bit more sense in that water freezes at 0 degrees, boils at 100 degrees. The problem is you can't have negative energy. You can't have negative movement. And so that's where our good friend Kelvin came from. And so absolute zero, when you hear that, that means there's actually no movement of particles. Okay, and so this is a theoretical temperature that you're going to get so cold that particles don't move. They've been able to kind of extrapolate where this will occur. Last I checked, I don't think they've actually gotten that cold. They've come close, and that's actually 273 degrees below 0 Celsius. Okay, so water freezes at 273 degrees Celsius. It boils at 373 degrees Celsius. And so because of this and because of the calculations, the standard units that we use in scientific calculations are going to be Kelvin. You won't have to calculate anything in Kelvin here. But oftentimes, especially in science, we discuss or we use the units of Celsius. And so Celsius equals 5/9 times Fahrenheit minus 32. Okay. For every change of 10 degrees of Celsius, for every 10-degree change of Celsius, that means we're changing Fahrenheit by 18 degrees. Interesting fact that negative 40 Celsius and negative 40 Fahrenheit are the exact same temperature. All right, so if we're looking at this scale here, so we've got Celsius on top, Fahrenheit on bottom. So if water freezes at 0, 32. All right, and then notice we go by 18 Fahrenheit, that changes Celsius by 10. Okay. Core temperature is normally around 37 degrees Celsius, but as long as we're between about 35 and 40 degrees Celsius, life's okay. But 37 degrees is the same thing as 98.6. And that's where we're going to end for this lecture.